Dado Automotive. Dado Automotive. In this video, we're going to explore electric motorbike. We'll explain what it is, how it works, the main components, how to control and switch all systems, how to operate the lighting systems, and even how to drive forward and backward safely. An electric motorbike runs using electric power stored in batteries instead of gasoline. The electric energy is converted into mechanical energy through an electric motor, which drives the bike's wheels. The system is efficient, quiet, and eco-friendly. That means no fuel tank, no exhaust, and no engine oil, just clean, silent power. Let's take a closer look at the main components of an electric motorbike. Battery pack. The battery pack is the heart of the electric motorbike. It stores the electrical energy that powers the motor and all other electrical systems on the bike. Electric motorbikes use lithium-ion or lead-acid batteries, but most of them use lithium-ion because they are lightweight, compact, and have a long lifespan. Some others use lead-acid batteries. The battery provides direct current DC voltage, usually in the range of 48 to 72 volts, depending on the design. Motor controller. The motor controller acts as the brain of the entire electric drive system. It manages the power flow between the battery and the motor and ensures smooth operation. The controller receives signals from the throttle and various sensors, then adjusts the voltage and current sent to the motor based on the rider's input. The controller also converts DC power from the battery into alternating current, AC, signals that control motor speed and torque. In addition, it provides safety functions such as overcurrent, overvoltage, and temperature protection. DC converter. The DC converter steps down the high voltage from the main battery pack to a lower voltage, typically 12 volts, to power accessories such as lights, horn, and dashboard systems. This is necessary because these components operate on a much lower voltage than the motor or main circuit. The converter ensures that all auxiliary systems run safely and efficiently without draining the main power excessively. Electric motor propulsion unit. The electric motor is the component that converts electrical energy into mechanical energy to drive the bike's wheels. There are two main types of motors used in electric motorbikes: hub motors and mid-drive motors. A hub motor is built into the wheel hub and directly powers the wheel, while a mid-drive motor is mounted in the center and delivers power through the chain or belt system. Throttle speed control. The throttle is the rider's control for speed. It works similarly to a traditional motorcycle throttle but sends an electronic signal instead of controlling fuel. When the rider twists the throttle, it sends a variable voltage signal, usually between 0 and 5 volts, to the motor controller. The controller interprets this signal and increases or decreases the motor's power output accordingly. Some bikes use twist throttles, while others use thumb-operated throttles. Braking system. Electric motorbikes use both mechanical and regenerative braking systems. The mechanical brakes, usually disc or drum types, provide direct friction-based stopping power. Regenerative braking, on the other hand, converts some of the kinetic energy of the moving bike back into electrical energy, which is fed back into the battery. When the rider applies the brakes, sensors signal the controller to stop the motor and, if applicable, activate the regenerative process. This not only improves efficiency, but also slightly extends the riding range. Display or dashboard. The display or dashboard provides real-time information to the rider. It shows parameters such as speed, battery level, power mode, distance traveled, and fault warnings. Most modern dashboards are digital and connect directly to the controller and BMS. Some even include Bluetooth or smartphone connectivity for additional monitoring and data recording. 3-position switch. A 3-position speed range selector switch on an electric bike is a multi-speed control switch that allows the rider to choose between 3 different speed or power levels, typically low 1, medium 2, and high 3. It is usually mounted on the handlebar and connected to the motor controller, which adjusts the motor's output power according to the selected mode. This switch helps balance speed, power consumption, and battery life based on riding conditions. The main function of the 3-position speed range selector is to limit or allow the flow of current from the controller to the motor, thereby controlling the maximum speed and torque of the bike. It provides flexibility for the rider to switch between different riding modes, such as low speed mode for smooth starts, city traffic, or conserving battery; medium speed mode for normal cruising or moderate riding conditions; high speed mode for open roads, higher torque, and maximum performance. By selecting one of these positions, the rider can manage energy efficiency, motor temperature, and overall bike control easily. Forward and reverse switch. Some electric motorbikes are equipped with a forward and reverse switch, which allows the bike to move in either direction. When the switch is toggled, it changes the motor's phase sequence through the controller, which reverses the motor's rotation direction. This feature is particularly useful for maneuvering in tight spaces or parking. Forward mode is default setting. In this mode, the controller drives the motor in normal rotation. When you press the reverse switch and twist the throttle, the controller changes the motor's polarity, allowing it to rotate backward slowly. Always we have to use reverse mode gently because it's not meant for high-speed movement, only for backing up in narrow areas. Lighting and accessories. Electric motorbikes include several lighting and accessory systems similar to those on traditional bikes. These include the headlight, tail light, brake light, turn signals, horn, and dashboard display. These components improve safety and provide the rider with essential information like speed, battery level, and distance traveled. All these systems are powered by the DC converter and controlled by switches mounted the handlebar. Headlight switch. This controls low and high beam for night riding. Indicator switch. This activates left or right signal lights. Horn button. Operates directly from 12V DC circuit. Brake light. Automatically turns on when you pull the brake lever. All these systems ensure visibility. Charger. The charger is used to replenish the battery's energy when it is low. It converts alternating current, AC, power from a wall socket into direct current, DC, suitable for charging the battery. The charger connects to the bike's charging port, and the BMS regulates the charging process to prevent overcharging. Most chargers automatically shut off once the battery reaches full capacity. Battery Management System, BMS. The Battery Management System, or BMS, ensures the safety and performance of the battery pack. It constantly monitors each cell's voltage, temperature, and charge level. The BMS balances the charge among the cells to maintain uniform performance and prevent damage caused by overcharging or overdischarging. It also provides protection against overheating and short circuits. By managing these factors, the BMS helps extend battery life and ensures safe operation of the entire system. Frame and chassis. The frame and chassis form the structural base of the motorbike. They support the motor, battery, and all electrical and mechanical components. Electric motorbike frames are designed to handle the extra weight of the battery pack while maintaining balance, comfort, and stability. The materials used are usually steel or aluminum alloys to ensure strength and durability. If you enjoyed this video and want more videos about electric vehicles and maintenance tutorials, don't forget to like, subscribe, and hit the notification bell for upcoming episodes. Thanks for watching.